Hello learners, welcome back to Organic Chem Wars YouTube channel. Today we will learn some more concepts while we solve an organic chemistry question. Remember, the more questions you solve, the smarter you evolve. So let's get started. First, let's analyze the question. So we have a phenol molecule. It is treated with aqueous NaOH followed by bromine, which is excess. Then it forms a product. What are the intermediates we can expect for the given reaction? Now, what happens the moment phenol reacts with NaOH? First, let me explain the question and answer in detail. Then I will give you a trick how to solve the question under 1 or 2 minutes max. Okay, so let's get started. So we have phenol molecule. When it is treated with NaOH, which is a base, the reaction is acid-base reaction because phenols are slightly acidic in nature. Therefore, it's going to form a salt. When an acid like phenol reacts with NaOH, it's going to form salt and water. What is the salt here? Sodium phenoxide. Look at the name, sodium phenoxide. That is the name of the salt, and of course the water will be the byproduct. Now, what happens to the phenoxide when it reacts with bromine? The phenoxide ion will undergo bromination, which is an example for electrophilic substitution reaction because aromatic molecules like phenol will undergo electrophilic substitution reaction. So let's see where the bromination will take place. In order to understand this, you need to know that phenoxide ion, the oxygen present here, right, it donates electron to the benzene ring, making benzene ring more electron rich. Why so? Because there is a negative charge. That means there are 2 electrons. It is donated to the benzene ring through resonance. That means there is a positive resonance effect here. So let's quickly write down the resonating structures. How to write the resonating structure? When the electrons are moving from atom to bond, look at this. There is a double bond here. Now this carbon cannot have 5 bonds. What happens? Immediately the pi electrons will shift here. This is the negative charge formed at the ortho position, right? So the arrows will help you to find what is the next structure. Therefore, first you write down the arrows, right? Atom to bond, bond to atom, right? Now, this is not changed. You write down that as it is. Now, the electrons are moving here. This is unchanged. What is not changed? You write down that as it is, right? The electrons are moving to para position, right? So now, the para position electrons move from atom to bond, bond to atom. This way it's easy to remember how to write the resonating structure. Look at this. What is not changed? You write down that first. The electrons are moving here. Make it a bond where the electrons are moving to the ortho position. Now it should revert to the oxygen. So you write down the structure of the last molecule here because you got back the same molecule here, right? So but look at the difference between this and this. Wherever the double bond was there, now the single bond. Wherever the single bond is there, double bond. That means you have written all the resonating structures correctly. Now, what are these resonating structures? It shows that the movement of electron is taking place and the molecule can exist like this, like this, like this. That means neither of them exist like a single molecule like this. Okay, they all exist as a hybrid. Therefore, how do we write the hybrid structure? You see, wherever the sigma bond is there, you write down that like this. Where is the double bond? Sometimes here, right? So the double bond can exist like this. And what about the sigma and pi? All of them exist like this. And what about oxygen? It's partially negative, and look at the ortho position, that is also partially negative. Now, why did we write all this? To show that there is a negative charge on on ortho and para, right? Therefore, the bromine as an electrophile, that is Br plus, will attack ortho and para position, right? So look at the options where we have ortho and para position. We have it in option C, that is only at the para position. Now, can it attack ortho? Yeah, it can attack ortho also, because O minus is electron rich. It donates more and more electron. Therefore, on ortho and para, both the position bromine can exist. Therefore, the right option is option A and C. Now, why not B and D? Because both the bromines, when it goes to para position, the molecule is losing its aromaticity. This is not correct, because the molecules are more stable when they are aromatic in nature, like in case of the phenoxide ion. Therefore, this cannot be possible. Now, why not D? Because here it is a phenol. We have a reaction which is an intermediate, so it's a phenoxide. Therefore, this is also not correct. So what is correct here? Option A and C. Both the options are correct. Now, let's come to the bonus point, bonus tip for you guys. What is it? That whenever you have a phenol and you want to identify that the molecule is phenol, that means you have to test that it is phenol, then this reaction can be used. There are two ways to decide whether the molecule is phenol or not. How? When you treat with bromine water or bromine, the color of bromine is brown. When it reacts with phenol, it decolorizes this bromine because it's reacting with the bromine. That's why. So there is a decoloration of bromine that indicates that the given molecule is phenol. Also, whenever you treat with excess of bromine, the reaction won't stop at the dibromo. It can form a tribromo product, which is a white solid. The formation of the white solid also indicates that your reactant molecule is phenol. So this test is used to indicate the presence of the phenol. That is the bonus tip for the given question. Alright, now I'll tell you how to solve this question under 1 minute. In order to do that, you should know the basic concept, that is electrophilic substitution for the benzene. And when we have phenol, it's a electron donating, and especially if it is O minus, it donates electron at ortho and para, making it more and more electron rich. Therefore, the bromine goes to both ortho and para. Where do we have ortho and para? We have it in A, C and D. We have to ignore D because we should know that the first reaction taking place is between an acid and base. That means it has to be phenoxide. So it cannot be D. So it has to be A and C. And definitely you should not choose B because it's losing aromaticity. Hence, you can go ahead with the option A and C. This is how you have to solve a given question under 1 minute. And this happens only when you know the concepts. Alright, I hope I made this concept clear, and if you have any question, you can always drop your questions under the comment section. Thank you for watching this video.